This is section 2.2, part C, on multiplying polynomial functions. In example 20, I'm given two functions, f of x and g of x, and I want to find each of the following. First, f times g of x, so I'm going to multiply the function f and the function g. So the function f is 2x minus 3, and I want to multiply that by the function g, which is 3x squared plus 4x minus 7. Remember that the of x in parentheses here just means to keep the variable as x. It does not mean multiply by an additional x, just like the f of x notation had x just declaring what the independent variable is. So I'm just multiplying the two functions f and g to get a new function for the product. I'm going to need to do a distribute here. I'm going to distribute 2x across the entire trinomial. That's going to give us 2 times 3, so that's 6, x cubed. 2 times 4, so 8, plus 8, x squared. And 2 times 7, so minus 14x. Now I need to finish the distribute by multiplying the negative 3 by everything. It's going to give me negative 9 x squared, and I ran out of room, so I'm right underneath. Negative and a positive, so negative 12 x. Negative and a negative, so positive 21. Final answer is going to have me combine my like terms. So the first term is still going to be 6x cubed. For the x squareds, 8 minus 9 will be negative 1, just negative x squared. Negative 14 minus 12 is going to be negative 26x. And last, plus 21. Now part B wants us to find f times g of 2. Since I've already found the function for f times g of x, I can plug negative 2 into it to evaluate f times g of negative 2. So this should be 6 times negative 2 cubed minus negative 2 squared minus 26 times negative 2 plus 21. If I hadn't already found f times g of x, I might have found it first anyway before evaluating f times g at negative 2. Okay, so negative 2 cubed is negative 8, so I've got 6 times negative 8 minus negative 2 squared is 4. Two negatives are going to make this 26 times negative 2 a positive 52 and plus 21. Keep combining. 6 times negative 8, that's negative 48, minus 4 plus 52 plus 21. Okay. Negative 48 minus 4 is negative 52, plus 52 is 0, so the entire answer should come out to be 21. You can use your calculator to check. In the next example, I want to evaluate f of x at a plus 4 to find f of a plus 4. Okay? So it's a minus 4. F of a minus 4 is what I get by plugging the expression a minus 4 in for x. So anywhere I see an x, I'm going to replace it with an a minus 4. So I have a minus 4 squared minus 3 times a minus 4 plus 1. I need to simplify each of these pieces. The first piece is a minus 4 squared, so I have a binomial squared. I know that to be able to do that, I need to write my a minus 4 twice and multiply it all the way out. Okay. I'll get to that in a second. The next piece, I know I can distribute the monomial and write that out right away. So negative 3 times a is negative 3a, and negative 3 times 4 will be plus 12, and then I still have the plus 1 from the end. Okay. Before I can combine like terms with the a's, I need to finish this binomial distribute, so we're going to get to that piece next. So I've got a times a is a squared, a times 4, so it's negative 4a. Continue, negative 4 times a, another negative 4a. Negative 4 times negative 4, positive 16. Then we have minus 3a, and I might as well combine the 12 and the 1 already to do plus 13. Kind of out of space here, but we'll just take some of part B's space. Okay. Last, just a few more like terms to combine. So my answer is a squared, negative 4a and negative 4a add to negative 8a, minus another 3a is going to add to negative 11a. Negative 8 plus negative 3 is negative 11. Then I have 16 plus 13 adds to 29. So that is f of a minus 4 expanded and simplified. In part B, I'm asked to write the function g of x in standard form. Standard form is going to have all the terms written separately, so it's going to have it simplified and combined down into shortest form. So what we want to do is expand. So I'm going to take negative 2x, and instead of writing the x plus 3 squared, we're going to write the x plus 3 times x plus 3 because I know I'm going to have to distribute that binomial multiplication as my first step. Okay, so I start with negative 2, leave that part alone. X times x is x squared. X times 3 is 3x. Then 3 times x is another 3x, and 3 times 3 is 9. Finish after the parenthesis plus 4. Okay, now I've got another distribute to do. Well, actually I need to combine my like terms first. So I've got negative 2 times x squared, 3 and 3, so 6x plus 6x plus 9. And then the plus 4 is not part of the distribute, it's after the end. Distribute your negative 2 into everything to finish your monomial distribute. Negative 2x squared minus 12x minus 18 plus 4, and finally combine your like terms. So my final answer, in standard form, g of x is going to be negative 2x squared minus 12x minus 14, because negative 18 plus 4 is negative 14. Okay. Let's look at the next page. Example 22. The average cost for tuition at a community college can be modeled by the equation for C of t, where t is the number of years since 1990, and the total enrollment at the community college can be modeled by the equation E of t, again, where t is years since 1990. First thing I want to do is find the product function for C times E. Okay. So C times E of t is going to be the function that I get by multiplying C, which is 55t, plus 832 times E, which is 0.15t plus 3.84. Okay, so we're going to do our distribute. Definitely going to grab my calculator for this one. First thing I need to do is take 55 times 0.15. I don't know what that comes out to be, so let's find out. 55 times 0.15 is 8.25. So we start with 8.25 t squared. Then I need to take 55 times 3.84. So I have plus 211.2 t. To finish the distribute, we need to take 832 times both of those values. So 832 times 0.15 gives me plus 124.8 t. And last, 832 times 3.84 gives us 3,194.88. Okay, I need to combine my like terms. So we end up with 8.25 t squared, plus I need to add up the coefficients of t, so the 211.2 plus the 124.8 gives us plus 336t plus the 3,194.88. So that's the equation for C of t. In part B, I'm going to use my equation to predict C times E of 21, and then I want to explain what it means. So first I want to plug 21 into the equation that we just found. So C times E of 21 is going to be equal to, so I've got to do 8.25 times 21 squared plus 336 times 21 plus 3,194.88. 0.88. 8.25 times 21 squared plus 336 times 21 plus 3,194.88 gives me 13,889.13. Okay, now I want to explain what that means. And when I explain what something means, remember that you always need to talk about the value you plugged in and the value you got out. So the value that you plug in is a t value, so that must be referencing our year. And don't forget that your years in both of these functions were since 1990, so this t value must be since 1990. So we can start our sentence with in. Okay, 21 years since 1990. 1990 plus 21 is going to be 2011. So in 2011, and we got to figure out what happened. So we multiplied the c function and the e function. The c function is the tuition in dollars per student, and the e function is the enrollment in numbers of students. So if I take dollars per student times millions of students, I might want to write this out, but dollars per student times millions of students is going to give me dollars, millions of dollars. Okay, so just to write this out on top up here, if I think about my units, dollars per student, per means divide, times millions of students. That's not a fraction because there's no per. You could put over 1, but students in the denominator, students in the numerator cancel. The units left in the answer are going to be millions of dollars. Okay? So in conclusion, in 2001, this one is the average cost at a community college, and this is the enrollment at all community colleges. So in 2011, we need to conclude that all community colleges had a cost of $13.889 million. That's the cost for all students at all community colleges altogether. Okay, so all community colleges, parentheses, just to make it extra clear, all students combined, all community college courses, all students combined cost $13,889.13 million in 2011. Okay, so hopefully that makes some sense. My sentence wasn't super elegant, but hopefully the explanation there makes sense. In 2011, the cost for all community colleges and all students was $13,889.13 million. Now, the last part, part C, I want to use my graphing calculator to determine whether the function c of e is increasing, decreasing, or neither for values of t between 0 and 50. Okay, so to do that, I'm going to graph the equation. So I'm going to go into y equals, I'm going to graph my c of t function, so 8.25, use the variable key for the variable, so it looks like x squared. Variable key is right here. Plus 336x plus 3,194.88. I'm going to go ahead and manually change my window right now. Two things. First of all, I know that I want to graph it for values of t between 0 and 50, so I'm going to make sure that my x min is 0 and my x max is 50. My y values, I don't necessarily know what the largest and smallest need to be, but I know that negative 20 to 20, which is what I had in there for my previous question, isn't going to work because super high values like 3,000 or in the 21st year, 13,000. So I know that since 21 is in between 0 and 50, I need to be much bigger than 13,000. So I'll leave my y min at negative 20. That sounds fine. My y max, I'm going to start with trying 25,000 just to make sure that 13,000 is going to kind of be in the middle of that window, and we'll just kind of see what happens. So here's the picture. You can see this function is, I don't get to see the whole function across the entire interval, but I think it's not going to turn around, and I can make a conclusion that it is increasing on this interval. So your picture looks something like this. And my conclusion is it's increasing. Finally, I have to do the last bit about what does that mean in the situation. So write a little sentence about it. And it means that the amount spent on community college education for all students is increasing each year. So the amount spent at community colleges. Now, because I was specifically given a window, 0 and 50, I'm going to use that window in my explanation. So I'm going to say it's increasing between 0 would have been 1990, and 50 would have been 1990 plus 50 is 2040. So again, this is a prediction that it's increasing between 1990 and 2040. That's the end of the section.